Okay, good morning, CCTI AP Calc students. Mr. Bashar here once again. As we get closer to the AP exam on the 12th at 2 p.m., I thought today I'd just go over an old topic, which is continuity. Just want to review this briefly because you never know, this problem, this type of thing may creep up into one of those open-ended problems. So it'd be good if we kind of just review this idea, and then you'll be in good shape. So when we talk about continuity, remember what this means. Essentially, a function's continuous. So if we could put our chalk on the board, draw the graph without lifting our chalk back up off the graph. So in terms of limits, we know that the limit has to exist at that point for something to be continuous. So there's some criteria. For a function to be continuous at C, you need three things to happen. F of C must be defined, so that has to be the case. The second thing is the limit as x approaches c of the function that must exist. And remember what this entails. This entails that the left and the right hand limit have to be the same. And number three, of course, is that the limit as x approaches c of f of x is actually equal to f of c, meaning that the limit itself is the function value at c. And if you have those three criteria, then you know that your function is continuous at some value c. Okay? So we're going to look at a problem today where we have to find a hidden value that makes the function continuous everywhere. And we've done these a little bit ago, but it's been quite a while. So we're going to determine the value of c, and f is given as a piecewise. So f of x is the function x plus 3 if x is less than or equal to 2, and it's cx plus 6 if x is strictly greater than 2. Okay? So there's our piecewise function. We want to determine the value of c, so this function is continuous everywhere. So a good place to start is actually the top function, because we have the less than or equal to. So whenever you see the equal to part, that's what we're checking out for if that function's defined there. So let's see. So notice we'll say f of 2 is going to be 2 plus 3, which equals 5. So 5 is that value that our limit has to be, and if it is, then we know it's continuous at x equals 2. So this is continuity at x equals 2. That's what we're checking out here. The second thing we're going to look at is the limit as x approaches 2 of f of x. So we got to check this out here. So the first step is we're going to look at the limit as x approaches 2 from the left. So if we're approaching 2 from the left-hand side, we're going to be using the top function, x plus 3, because that's less than or equal to 2. So the limit as x approaches 2 from the left of x plus 3 is the value of 5. Now we have to check the limit from the right-hand side. So the limit as x approaches 2 from the right-hand side, that's going to be this function here, cx plus 6. Okay? So what is that going to be? Well, if you plug in 2, that's part of the problem. But what does this have to equal? Well, we found out that this is 5, and the function evaluated at 2 is 5. So we got to get this thing to be 5 so that the limit exists there from the left and the right. So we'll write it like this. The limit as x approaches 2 from the right of cx plus 6 is 5. So go off to the side. Cx plus 6 equals 5. We know that x is 2. So essentially that's going to be 2c plus 6 is 5. We'll solve this thing for c, because c will be that magic number. So 2c is negative 1. So c is negative 1/2. Let's go and check to make sure this makes sense. If you plug negative 1/2 in here, right, now our function is the limit as x approaches 2 from the right of 1/2 x plus 6. let's see, you plug in the -1/2 right there. So -1/2 times 2 will be -1, and -1 plus 6 is 5. That 5 matches with that 5, so that means that we have the third condition to work then. See, 5 and 5, left and right, that means the limit exists, so we're good there. And the last condition is, well, the limit as x approaches 2 of f of x must be equal to f of c, or f of 2. And that happens because what we have there is the limit as x approaches 2 of f of x is 5, which is equal to the value of the function evaluated at 2, and you're done. So this one wasn't too bad, but I think it was noteworthy to go back and review. Okay? So in the email today, you'll see a problem like this, and there's other practice problems. The answers are included for some of them. So I would encourage you at some point today to work through some of those problems. Okay? Other than that, the sun's out today. Maybe you want to take a walk or something outside. It's supposed to snow tomorrow on Saturday. It's really messed up weather. But could we expect anything else at this point, right? So enjoy the rest of your day. Be good, and I'll see you next time.